Okay, for this one, so the Z-score is 11. Don't forget to put it right
No, so you guys are worried about this number 3. I know that's the number 3, but that's thing, right? It's a thing. It's not something to worry about mathematically. We'll be talking about costs of plungers. This is a 3-bedroom flat, a plunger, a toy, whatever. So if I draw this picture, hopefully you start to realize every problem we do like this is the same problem. Some of you guys realize that. That's the big key thing, is to realize that they're all the same problem. You guys don't see that? What goes right in the middle? 324, that's the mean. And I'm interested in those 2 points, right? 330 and 350. So which one was it? This one. So I'm going to put 330 and 350 here. Good question. Now if I change those both into z-scores, and then I'll look up both of their areas, I can subtract those. That's the idea, right? I want to find these areas, because I can subtract and get the area between those two. So what do you get for the z-score of 330? Yeah, I think most of you guys are getting, for 330 it was 0.09, right? And for 350, that's the one you got the 0.39. Again, why we rounded to 2 places? Because the chart goes to 2 places, so it kind of makes sense. Please know how to round. Okay, it's something we should be coming in this class knowing. And you can see how important it is. I mean, you don't want to round something. How much will it cost, about Johnson? 5,000. I mean 10,000. That's kind of a huge deal. You gotta know how to round. So 0.09, when I look at that area, what do you get?
0.5359.
Who do what?
0.5359.
5359. Where's that on the picture? So 0.09 is this one. So it's going to be below there. So 0.5359. So that area right there is 0.5359. And then the other area, the bigger area, when I look at 0.39, what do you guys get? 6517. And if I subtract those 2 areas, I'll be left with the area in the middle. That just makes physical sense. It's awesome. So what do I get when I look when I do subtract these? 0.6517 minus 0.5359. I get 58. 0.1158. Yeah, looks like it. So 11.58%. Cool. So again, what's a way to interpret that? How can I interpret this? Yes, cool. 11.58% of the 3-bedroom flats in this area cost between those 2 prices. Or you can say the probability that I pick one that cost between those 2 is this probability, this percentage. I like it. The one that's a little bit better is the first way that we just said it, because it makes a little more physical sense, right? Saying a probability doesn't really make physical sense to us as much as saying, well, that percentage of the flats cost between, oh, okay, that's that. I can see that. I can kind of get an image of that. This is the one that goes backwards. It starts with the percentage. So I've got to make that back into a z-score, make it back into a rent in this case, a raw score, an x. So when I look up 0.15, the closest I can get is kind of a nifty history lesson, right? 1492, Columbus sailed the ocean blue, killed a lot of Indians, and somehow we got over it. We don't learn all that shit normally in high school, we learn about it later. Not directly necessarily, but certainly in the record. And then the record. So 0.1492 is the closest I can get to 0.15. And what's the z-score related to that? Negative 1.04. You guys see that? If I know a z-score, I can find an area by finding the z-score and going in. If I know an area, I can find a z-score by finding the area and going out. It works both ways. I like it. So the z-score I'm working with is negative 1.04. So now I can use that to convert it back into a raw score. Not used to this thing. Now real quick, I really want this formula to make stupid amounts of sense. To be the 15th percentile, it has to be below the mean. The formula says mu plus z sigma, so the only way I'm going to end up below the mean is if I'm subtracting, and that's why a negative z-score makes so much sense, right? Because I end up subtracting from the mean. It's supposed to be below the mean. Oh my God, it makes sense. Okay, I like it, maybe. So now I just got to plug stuff in. So then we know the mean was 324. Put negative, but I'm just going to put, follow exactly the formula. Negative 1.04 times standard deviation 66.9. And you throw all that in your calculator, what do you guys get? 0.4? 2.4, so we'll say 242. They get a nice price. I like it. So if you were paying that much money for rent in that area of New Zealand, you would be in the 15th percentile. Is that a good thing? Is a low percentile, in this case, good? Hell yes. So there's a whole section of the homework about Mina's waiting time for the DMV, and should this guy be pissed off about his repair costs for his car, that whole little area that a lot of you guys kind of either just copy from the interview or just kind of skipped. No, you got to know how to interpret this stuff, right? You got to know what the number means when you get it. It's about time to go yet. And then I gave you just another little problem here. More than $585 a month. So again, right in the middle goes the mean. 585 is way the hell up here. More is going to be up there. So I know it's going to be a relatively small answer. Maybe we don't realize how small until we get there. Make a z-score. What do you get for the z-score to cut to the chase? I think you get 3.90, right? Which will freak you out a little bit. So I disagree with the chart. Their approximation works up to a point. They say 3.5 and up is that. I hope to God it makes sense that the further you go up on this normal curve, the more and more and more and more you're going to have below you. So eventually you're going to have 0.999999999999999. Shit. So normally I say either do what the chart says, because it's printed and it's accepted and what they should, or do the better thing and say, I would say this is about 0%. It's not 0, is it? It's not 0, right? What's the matter? Because I want the area above. If the area below is either 0.9999 or about 100%, then the area above is going to be 0.0001, which a lot of you guys got, and is fine. Or approximately 0% is also good. What does it approximately mean? It means it's not actually 0. It's just so damn close to 0, might as well be. Maybe? Do you guys see that? How that chart kind of gives up towards the end? You can only do so much. But we can be a little bit better. And I'm really the main purpose for this was I knew several people missed last class. I knew a lot of us needed more practice with this. We're about to get into how does this whole process change a little bit if there's some certain thing going on in the problem. Well, we better know this freaking process before we start tweaking it, right? So this is just a bunch of, this is your standard z-score problem. Some of you guys realize it is the same thing over and over and over. For this one, it's the same exact idea as before, but now what goes in the middle? Yeah, 2702. And I'm interested in the 21 and 2400, right? So 2100, 2400. The area between. So again, that sounds very familiar. I find z-scores, I find areas, I subtract them to get between. What do I get? Okay. So what do you guys, the z-score for 2100? Negative 2.3?
Oh, 3.
2.03? And the z-score for 2400?
Negative 101.
I like it. Which makes sense because that's almost $300, right? The standard deviation. And $300 below 2,700 is 2,400. So that should be about a step down, and it is. And that should be about 2 steps down to 2,100. It's another 300 down. So those make sense. You've got to find, if you can't find something, now this is going to be a funny thing to say for some of you especially. If you can't find something that makes sense in a math problem, you're not looking at it correctly. It has to make sense. I love it. And especially in statistics, it actually has to make physical sense. Very, 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 very freaking often it has to make physical sense. Now I look up the areas. What area do you get for negative 1.02? Let's start there. Have we gotten ahead of you guys? Anybody look that up? That should be for the 203? Okay. So do that one again. 0.0212, I like it. And then for the negative 1.02, 0.1539. So that's too much. If I subtract that off, that'll leave me the area in between. It only makes physical sense. So when you subtract those, what do you get? 0.1327. So just a little bit over 13% of San Diego's 3-bedroom apartments would cost between $2,100 and $2,400 a month. If you are not yet paying rent, you have exciting times in your future, I tell you. Big chunks of your income just go. Probably the rent's below $2,650, same idea, right? 2,702 in the middle. 2650 over here somewhere, below 2650. So I just wanted to throw at you a few different situations, just so you get used to. You get a z-score, you look it up with a chart. All right, that's your main things for right now. So the z-score you get, what do you guys get for that? Oops, I remember what was that? 296.64. What gets over? What do you guys get when you do that z-score? Anybody do that? Negative 0.18. Okay, sounds like we have consensus. And then if you look at negative 0.18, looks like you get 4286. I like it. So this is acceptable to put your answer up there. Just please do that. Circle your answer. There's a lot going on in these problems. I need to know what you consider the answer to be. Oh, good. We got time. Okay. Let me not do this one yet. It's a little involved. Let me go over the general idea. Okay. So, I can't remember now if I did this with you guys. There's like a parallel universe Florida. We go down there and we ask people, how old are you? So we get a bunch of young people and a bunch of older people. Where's the mean age, just from this distribution of ages? In the middle. How did I just totally made the shit up, but let's pretend like I actually did this. How would I have made this picture? Where did this come from? What does this mean? That's the tallest point. So these are ages, right? Let's say this is from 0 up to 120. Right? So if you live to be 120, 60 would be middle age. Oh my God. How would I have made this picture? I mean, what am I walking around asking people? How old are you? Right? And I'm like, I don't trust you. Show me your ID. And then I look at their ID and I say, oh, you're 23. Pop! Right? And then all the 23-year-olds going to stack up on each other so that you guys get the feel for what's happening. So I created this picture by getting individual ages and putting them up here. You guys with me? I'm making a big deal out of that because it's going to relate to what's going to happen next. Where's the mean, roughly? Like roughly right here, right? Maybe a little bit closer down because it seems to be bulkier down here. There's more lower ages for some reason. How's everybody doing? Is that cool? Okay, maybe. So the mean's in there somewhere. And let's say the standard deviation is like whatever it is. The standard deviation is this big. So how much, if I go up and down one step, up and down one standard deviation, what percentage do I get? I catch 0. So this is that Chevy Chev thing. I can't remember if we talked about that Chevy dude. No? Okay. That's fine. The real big thing that's going on here today is what happens if I take what we normally do in statistics. I take a sample of people, not one person at a time, but I take a sample of like, let's say 50 people. Well, let's start with, let's say 10 people. I take a sample of 10 people. And I say, what's the average age? You guys talk amongst yourselves and then tell me the average age. You guys, if they don't really know math, I say, give me your numbers, I'll do it for you. But I get the average age for every group of 10. Is everybody with me? So instead of saying, how old are you, I take 10 people and say, how old are all of you on average? And then I plot that point. So it's going to be a different distribution. It's going to be a distribution of sample means, right? I'm going to put dots where the means go. So what's going to be the most likely thing if I randomly pick people? Well, I randomly pick a bunch of people that were just born. If I randomly pick people, will that happen very often? No. Will I randomly pick a lot of people that are, 102? No. What's going to be the most likely thing? Well, there's nobody near the center, right? But at the end there will be. But what's the most likely random sample I would get? A bunch of people from both, right? A mixture. If I randomly select people, nobody should necessarily be more likely. I mean, the higher points, there's going to be more of those. But I should get a mixture from both camps, right? The young camp and the older camp. Notice I keep saying older, not old. So if I take 10 people at a time, and then I plot the average age, not the age of each, but the average age, the picture's going to change. Now it's going to have, where's the highest peak going to be on this? What's the most likely average to happen? What's the expected value of the average for any sample? This. That's another name for it. So if I have a mixture of things from both groups, and that's the most likely thing to happen, the highest peak should now be on the mean. So now it's going to look maybe a little something more like this. Some other peaks related to those peaks. Are you guys with me? What has happened? So where's the mean? Oh, shit. I'm sorry. That was a little extreme, actually. Where's the mean of the means? Where's the mean of the means? It's going to be right in the same place. Please, dear God, get this idea. If I took one person at a time and then added your ages and divided by how many people are, I'm going to get the average age. If I took 2 people, averaged them, 2 people, averaged them, and then I averaged all those averages, will that be a different number than the average age? Why would it be? Why? Why would it be? Why would it be? Think about it. Think about it. If I took 2 people at a time, averaged their 2 people, average, 2 people, and then I average those averages, it's going to be the same average. Did the people in here change? Did you all suddenly become older or younger? Just because I took 2 instead of 1, you guys with me? Just because I took 2 people instead of 1 is not going to change the average age in the room. That's insane. So I started taking 2 people and he's like, I'm getting older. He chose poorly. No. Sorry. Little Raiders lost our So the mean of the means is the same as the old mean. It's the same. They're the same. Of course they're the same. They're the same people. But what happens to the standard deviation? Can somebody help me out there? Which picture would have a bigger standard deviation, the first one or the second one? Yeah, remember what standard deviation means. The average distance from the mean to the data points. Which one stays at its mean more often? This one. So which one has a bigger standard deviation? That one. It gets away from its mean a hell of a lot more often, does it not? What happened to this picture? It kind of went to the middle. Went to the middle. If I increase this to be 50, now get this is where it gets cool. If I increase it to be 50, now my picture is basically going to look like that. And my standard deviation is even smaller now. Okay. So the standard deviation of the means is the original one divided by the square root of the sample size. So as my sample gets bigger and bigger and bigger, my standard deviation of the means gets smaller and smaller and smaller. And think about it. If I took the entire population at once, what's the average going to be? The average. The standard deviation will be 0. I mean, if I let this go to infinity, it's just going to keep going up and be a single line right there. Maybe some of you guys follow that. So we'll get a little bit deeper into this idea. That's the whole idea on the back page of that is a concrete example of this weird abstract idea. Yeah.